Okay, so if you're familiar with this property, if you know how to do this, you probably are familiar. 1/3 plus 1/3 equals 2/3, right? When you add fractions, the denominators stay the same, the numerators add. So it's just a little bit tougher one for this one. So if you look at the denominators, they don't match, so I can't add these right now. Maybe if I kind of adjusted on the right and just on the left, I got a common denominator. So what's the common denominator between those two? Not that much different than this kind of thinking. 1/2 plus 1/3. If you want to add those two fractions up, this side would be multiplied by 2/2. This side would be multiplied over 3/3, and then we should be able to, I think, add those fractions together. 3/6 plus 2/6 is 5/6. So here, to get the same denominator, this right side needs an x minus 1. The left side needs an x plus 2. And so if you multiply that out, you get x plus 2 as your first term when that distributes, plus 2x minus 2. And the numerator really is all of that, x plus 2 times x minus 1. And like terms up top would definitely combine some, so that would be 3x. I was going to say minus something, but actually that's 0 over x plus 2 times x minus 1. Okay, let's look at this one. So before we start this one, you might even see there's some factoring to be done. I want you to always, factor if you can. So I saw that. I thought, well, maybe we could factor that. That would be 1 over x plus 2 times x minus 2 minus 1 over. I'm going to write it this way. I know I could just leave it like that, but I would just for kind of ease of understanding, maybe this would make more sense. Okay, so what is this side missing over here? So it looks like we don't have a common denominator yet. I've got two x plus 2's, but I don't have any x minus 2's. I need one of those guys, x minus 2. And what is this side missing? Like, I need two x plus 2's. I only have one, so I need another x plus 2. Now my denominator is the same. So the denominator is going to be the same. It is x plus 2 quantity squared times x minus 2. The numerator, that first parenthesis is going to be x plus 2 minus x minus 2. So that numerator would be x minus x is 0, 2 minus negative 2 is 4, so we have 4 over x plus 2 quantity squared times x minus 2. Okay, this is a pretty tough problem here. So this is called a complex fraction. The reason it's called a complex fraction is because, well, it's kind of complex. It's like a fraction within a fraction. You got a fraction in the numerator. That's one big fraction. That's the division bar. In the denominator, you also have a fraction. So it's a fraction inside of a fraction there. So it's complex, and it is kind of complex. So one method would be to get the same denominator. Right, we know we can add or subtract. If you can just get the same denominator, that will help. Sorry about that. Okay, so we have, in this one, this left-hand side here needs an x plus 1. And this needs an x plus 1 as well. So we have a common denominator. And so if I simplify this, let's see what we get. In the numerator, you've got, that's all going to be one fraction now. The denominator is x plus 1. Those will add together nicely. I've got x plus 1 plus 1. So I have x plus 2 if you followed that. And here in the denominator, we also have a fraction, x plus 1 is in the denominator. Be careful here, you're subtracting. So you have 1 minus x plus 1. So 1 minus parentheses x plus 1. So that will simplify, right? So the denominator would be 1 minus x. Minus 1 is really a negative x over x plus 1. And again, we still have the numerator x plus 2 over x plus 1. We're going to multiply by the reciprocal. In this case, that means we're going to flip the denominator, not the numerator. Okay, so this would equal to, the first fraction is the same, x plus 2 over x plus 1. The second fraction is going to be flipped, so this would be x plus 1 over negative x, I guess. Nicely, this cancels. And you get the final answer of x plus 2 over negative x. Put the negative in front of the function if you want. Typically, we don't love it in the denominator. Okay, so the second method of doing this one, I kind of like this method better. I'll be honest with you. So it's going to basically multiply by LCD, top and bottom, numerator, denominator, to get rid of fractions, So I'm going to multiply the one big fraction here. I'm going to multiply by x plus 1, which is the LCD of that denominator. And in the denominator, I'm going to multiply by x plus 1, which is the LCD of that denominator. So what should happen is the denominator should kind of going to go away. At least the complex part of the fraction will be gone. Let's see what happens when we actually multiply this out. So in the numerator, I'd have x plus 1 plus, distribute to this term, x plus 1 over x plus 1, which, by the way, would simplify. This is really x plus 1 plus 1, which is x plus 2 in the numerator. By the way, the answer is negative x plus 2 over x. Let's see if we get the same answer. I think it's going to work out a little faster. A lot of you will not really show this step, like that is equal to 1 there. That's fine. I just want to make sure you understand what we're doing first. So I'll show this step. So this would be, I guess it'd be x plus 1. Wow, that's doing some really weird stuff there. Let me try that again. I don't want that. I want just a regular pen. Huh. Okay, so this would be let's see, x plus 1 over x plus 1 minus, then distributes to the next term. That would be x plus 1 over, I guess, no, that would just be negative x. I guess if the minus is there, it'd be x plus 1, right? So this would be x plus 1, I guess over 1 if you want to think about it that way. So the denominator, really, I guess they could both simplify here. So x plus 1 over x plus 1 is 1 minus, distribute the negative there, so that would be minus x minus 1. So that simplifies to be just 1 minus 1 is 0, so that's just negative x. And again, our answer was this, which is the same answer. Here I put the negative in front. There's on the bottom. It'd be better to either put it in front or put it in the numerator. Make both terms negative or change the sign of both terms in the numerator. Rationalize the denominator. So it's one more concept of the conjugate. So if you have a factor a plus b, the conjugate of that is a minus b. Or if the original expression is a minus b, the conjugate is a plus b. And so this really helps to simplify, especially when you have a binomial in the denominator and there's a radical down there. Remember, we want to rationalize. So it's trying to make that a rational number. I don't like irrational numbers in the denominator. So we're going to multiply by the conjugate. And let's see what happens. It's actually kind of neat. So this would be the conjugate. If it's a plus b, the conjugate is a minus b. So A plus b would be 3 plus square root of 2. A minus b would be 3 minus square root of 2. And 3 minus square root of 2. So top and bottom, you're going to multiply by the conjugate. And if you distribute 1, there you get 3 minus square root of 2. All over. First times first is 9, minus last times last is 2, or square root of 4, which is 2. So we get 3 minus square root of 2 all over 7, which is simplified, or at least rationalized. There's no more irrational numbers in the denominator. So sometimes, I don't know why, well, in calculus we do this. We want the numerator rationalized. So we don't want to, we're okay with the denominator, we just don't want it in the numerator. So if that's the case, I would multiply by the conjugate. So the conjugate of that, if that's a plus b, a minus b would be square root of x minus square root of 5. Again, do that top and bottom, square root of x minus square root of 5. And you get x times x minus 5, or square root of 25. And this would be, distributes here, so it would be 2. You could just leave it like that, it would be fine. Square root of x minus square root of 5. Or you could distribute, that would be 2 times 2x, 2 times square root of x minus 2 times square root of 5. That would be as well, correct as well. That's the lesson. Thanks.